Thank you very much. Can everyone hear me okay? Good? All right, excellent. I'm really excited to be here tonight. Yes, maybe it's a sign of the times when it's 7 o'clock on a Saturday night, but it's exciting work. Looking at these wonderful little forage fish and to be able to share a little bit with you is my pleasure. It's wonderful. I do want to acknowledge that I am working and living and enjoying living in Roberts Creek, Xwesam. My pronunciation may not be the best, but in the traditional territories of this Coast Salish people, as well as Squamish and Tliamin. And so I've been living and working there for, almost 30 years now. So it's been a while. I will I was noticing there was some speaking about in the chat about where people have had their feet get wet. And I saw somewhere in there free diving and some other great comments and good stuff. It's always exciting to hear about where you get your feet wet. I get mine wet when I walk out the door half the time. Anyway, yeah, so I'm going to share my screen now with you, and we will carry on through my presentation here. Okay. There we go. Okay, so we're going to be speaking about forage fish today. And of course, my first question I'm going to have for all of you, and I do apologize if I don't get to all of you, but my question is for asking you, what is a forage fish? Or versus that, because that's a lot of writing, how about, or typing, give me an example of a forage fish that you know, okay? I see there's a few people that are in my Friends of Forage Fish sampling group, citizen science group. And so you're gonna know at least a couple of them right off the bat. Okay, so we will carry on. Okay, so what are forage fish and why are they important? There we go, I'm answering your wonderings already. So forage fish are food or forage, right, for hundreds of larger species, you know, including larger fish, marine mammals, birds, many, many different things. They're abundant schooling fishes, and they include herring, smelt, surf smelt, Pacific sand lance, anchovy, and many more. So you can think oolakins, capelin, menhaden, and on and on. So just extremely abundant little schooling fish. They're an essential component of marine ecosystems. They provide critical food sources for many birds and larger fish, such as salmon and lingcod, which in turn are eaten by marine mammals, right, such as sea lions or the orca or killer whales. So they're really, really important in the food chain. A little quote that I thought was quite interesting here was, variation in the availability of sand lance and other forage fishes can have major effects on the breeding success and survival of their predators. So how very true. And a couple of little photos I included in the bottom of the slide here is the marbled murrelet on the right, and on the left is a female rhinoceros auklet. And it has, of course, many of those sand lance, Pacific sand lance in its beak. Okay, so herring in the food web, and of course other forage fish. When we think forage fish, we often think herring, right? But there are many others, and they're every bit as important. But of course, in the past, herring was so numerous, it was so abundant, that was the one that everyone saw and thought about immediately. Herring, herring, herring. So if you're looking at this, there's my cursor. So you're looking here at the egg stage where these eggs are being laid. This is representing a piece of seaweed. So these would be the pelagic spawners. So the pelagic, such as anchovy and herring, which are offshore, so below low tide. If you look over here, if you can see my cursor, okay, over here is along the shoreline is where we're going to have a focus on today, and that's the Pacific sand lance and the surf smelt. Those are the two that are spawning in the high intertidal area. So you see where that bear is and along there. So they're actually up there when the high tides are in, and that's where they're spawning. Okay, so if you follow this around, you're going to see the juveniles. Juveniles, when they hatch out, are heading out. Now, sometimes they're so tiny, they're just washed out by the movement of the currents and the waves, the tides, and at the mercy of the ocean. Others will actually move themselves out into the shelter offshore to feed and to grow. And as they move along and they're becoming juveniles, they're now becoming food for the larger, well, anything bigger than them will eat them, basically, that phase. But once they get to juvenile stage and adult, they're food then for, okay, I've lost my cursor. There we are. They become food for the larger, the sea lions, the seals, the whales, and of course the salmon and the other larger fish. And here they are coming back once again to spawn. Okay, so here we are. These are the two prime suspects. These are the two that our Friends of Forage Fish group has been sampling for the last 12 years almost, on and off. The top is the surf smelt, this tubby looking one here, and below is the Pacific sand lance. So it's a quite long and skinny fish, and it is definitely living up to its name of sand eel. They're known as sand eels in some areas, and that little sand lance is definitely eel-like in its movements. So the Pacific sand lance and surf smelt use the intertidal zone for spawning. So think about where you have your beach chair and your picnic blanket. If you put it down and your picnic blanket gets wet, that's because the tide has been there, and that means that's an eligible place for those two to spawn. Their juveniles rear in the nearshore areas using vegetation such as eelgrass beds for cover and for food and for all of those things for survival. Our Forage Fish group has been sampling just for absence or presence of the species for about 12 years, on and off, not continuously, but on and off. And they work well for citizen scientists to study because access is easy there. You don't need to be diving, you don't need to be wading. You just need to be on that beach at the right tide time to collect your samples. Your samples are not something you look at. Those eggs are too small, but we'll get into that. You take scoops of sand. So it's an act of faith. And so the lack of information about these forage fish was also a major factor in our sampling program. So now let's take a look at some of the different forage fish. Okay, so there we are, the surf smelt. We've seen a picture now already. This female here is quite gravid. She's full of eggs, okay, at this point in time. So thinking about this fish coming in on a high tide, usually those tides are in the evening, in full moon, and in she'll be coming to lay her eggs. There below her is a juvenile, much more slender. And so they're high intertidal. Between the high tide and the low high tide is their favorite zone. They utilize the coarser sands in the beach, and their eggs are adapted to survive between the tides. So that just in the moist sand. So it doesn't have to be water. They just need moist sand to keep them going. Amazingly hardy little critters. In BC, the smelt are mainly spring and summer spawners, but spawning can occur year round. Timing is affected by the tidal and lunar cycles, and there's a marked increase in the number of spawners during high evening tides during the full moon. Overhanging vegetation, something that we really don't think about a lot, and we should be, is that overhanging vegetation. The first thing that goes when people build on the waterfront is vegetation along the shoreline for your view, for your access, whatever else. And that vegetation helps keep those eggs shaded and cool during their incubation period. In the wintertime, that incubation will take about 3 to 4 weeks, depending on temperatures. In the summer, as short as 2 weeks. So yeah, that vegetation is super important. The females produce between 15,000 and 20,000 eggs on average. Okay, so here's a surf smelt spawn site so that you get an idea of what we're looking at here. So this blue line represents the area where the potential spawning can happen. Surf smelt like a coarser sand. And so what you're looking at here, you know, you may say, oh no, this is looking, you know, way too difficult for this fish that's maximum 10 inches in length to manipulate and to, you know, be able to spawn there, but it happens, and it's quite an amazing thing. Okay, so this is getting into what those little eggs look like. So you see the scale here, that's half of a millimeter. So these guys run about 1 to 1.2 millimeters, very small. You notice something that I want you to keep your eyes on though, and that is here you can see the eye, you can see the body of the embryo, but on the bottom of this egg, you see here, this is actually a little appendage, I guess you could call it. It's called it's called a peduncle. I'm just gonna scoot us back. And that little appendage, I guess you could say, forms on the shell, and that's the mode that egg uses to stick to a grain of sand or another object in that area, okay? And that is how it anchors itself so that it can stay there, not be washed away with the tides and the movements of the water while it is incubating and growing. And here we are, there are some surf smelt, and they were known as sweevies. I guess they still are actually, by the Sechelt Nation, and were dip netted in Trail Bay. And this is from, I was speaking to someone from the band about this, and they said, yep, they usually went down with dip nets by bright moonlight in the evening. And that happened until the early 1980s. So a while ago, but not that long. And since then, they just not so abundant, not so common, and a shame. Next one we're going on to is the Pacific sand lance. And then these ones are pictures I took in August, a few years ago in Roberts Creek here, Xwesam. And these little ones had an interesting story. I heard from neighbors that there was these funny fish that were tumbling around dying down at the beach. So I zipped down there with my camera and waded out, and sure enough, these sand lance, you could see there's a sandbar, and the water was very, very shallow. It was probably less than a foot deep, and the gulls were zeroing in, diving down, and crashing into the water and coming up with something in their beak. And so I went in there and I saw these little guys tumbling in the shallower tide pool as I waded out that way. And so they were being hunted by the gulls, and not exactly sure what the problem was with these little guys. We speculated that they might have been oxygen narcosing, because they were turning up, they were belly up, they weren't all completely dead, but they were obviously not, there weren't enough gulls there that they would be all stunned by being attacked by gulls. So we were speculating that on the idea that these little ones somehow, because they hang out in the sand, were caught in an area with low oxygen, and were just narcosing and coming up. And as they did so, this attracted the gulls, in which in turn they would carry on feeding and catching more and more. They spend much of their lives buried in the sand, okay, especially in the wintertime. And that's where they get their name sand eels, because that's what they do. They burrow themselves into the sand, and they do that especially to avoid predators. They do not have a swim bladder. So they, you know, that is limiting them in a way, but they are common at depths of less than 50 meters, and that's it. So they don't really need to have the ability to raise themselves in the water column. So they spend a good time in the sand. They avoid muddy, silty areas, preferring clean, well-washed, unpacked sands, and they avoid oil contaminants and contaminated sediments. So their eggs are slightly adhesive. Now you saw that peduncle, that appendage on the surf smelt egg. These ones, the sand lance, have an entirely adhesive egg. So that means that they're all have, the entire egg has a little bit of stickiness and the sand grains attached to those newly laid eggs, anchoring them in place. And these ones, the females produce up to about 1,500 eggs or 1,600 eggs. And here we have, this is from Washington State. Washington State has lots more information on these fishes than we do. And so we have drawn heavily on their knowledge. You can see the spawn pits. There's one here and another here. And so what happens is when they're spawning, I'm going to show you this in a second, they are digging into the sand, and you can see shell hash, the white materials here, that's been dug up by their excavations, and their eggs would be laid in the sand in these areas. Okay, so this is a short little video I'm going to show you underwater. This is from Powell River. This is, thank you very much to Terry L. Brown, the amphibiographer. So if I can find my cursor again, I keep losing it. There it is. I will play this short little bit for you. Come back. There we are. Into the sand. There she goes, right in. And popping out. There we are. Okay, can you see the continuous dorsal fin all along the top of the body? And there we are. Okay, so those fishes would have been in the very shallow intertidal zone. And so they head into the shore and away they go for their spawning. So there we are. I want to show you now, we have in our group, the Sunshine Coast Friends of Forage Fish, volunteers, trained volunteers that analyze the samples to look for the eggs. So if you're looking at these ones, these are taking note, the sand lance has the entire egg that has an adhesive surface. So you're seeing these lovely angular sand grain segments on the eggs. And so that's what we're looking for. So when we're looking, that's what we are searching for. So the volunteers do this, dedicated crew. I give them kudos, many kudos. And this photo is the sand lance schooling together. So when they decide they're not going to be buried in the sand, they will come up and they will swim in these dense schools, as most forage fish do, for protection. Okay, so we're off to another different one. This is in northern Anchovy. I had the privilege of getting an email in, I guess, 2017 and a phone call about this event that was going on. And this was the Anchovy at the area of Soames Beach, and they were there en masse. And it was amazing. There were hundreds of gulls and ducks and sea lions, and there were seals. There were eagles all over the place. An amazing event happening. So I immediately, not knowing any differently, said, oh, it must be a spawn. So I went and took a whole bunch of pictures, rushed out to the papers and said, you know, I really need to get this word out that this is going on. And I was corrected by one of the people that studies them at UVic and saying that no, or anchovy don't spawn on the shoreline. They're not like the surf smelt and sand lance. So these anchovy are pelagic spawners. So that being said, they will swim out and they actually will spawn in the water column in the deeper water. So they spawn in the water column, they hatch, eggs hatch within a few days, depending on water temperature, once again. They live up to 7 years, and they're recognized by their long upper jaw, overbite, their overbite. They are summer spawners, and once again, 20,000 to 30,000 eggs. And there is a fishery for them. There's actually a small commercial fishery for anchovy, and that is mainly for bait, and mainly on the west coast of Vancouver Island, and conducted by Net. And this is what they look like. Now, the first time I saw these guys, I was actually going out fishing with my husband. We went to get some bait herring, and I looked down and I saw this. I saw these red spots happening in the water. And I said, you know, Dave, what is this? What's going on? These aren't the same fish. And he said, no, those are anchovy. And this is a characteristic, whoops, that they have when they are feeding. So they're bringing the plankton in and out under the gills. And so they somehow in the feeding process, they balloon out those gill covers, and you see the flashes of the gills underneath. And here we have a seal feeding on anchovy in Howe Sound, thanks to Bob Turner. And Howe Sound is now seeing quite a resurgence of anchovy that we're not seeing there for a good number of years. And so I hope that keeps up. Next, we're going to Pacific herring, or I'm going to be talking all your ears off, so I need to keep going a little. And of course, these are the ones that we know a lot about, or of the forage fish. These are the ones we know probably the most about. So they migrate to estuaries to spawn once a year. They spend about up to 2 weeks spawning, and they are intertidal and shallow subtidal. So just below the zero tide, and maybe a little bit up above. So they're tough little ones as well. They can survive out of the water for periods of time. They like to develop, put their eggs on, deposit eggs on kelp, eelgrass, and other available structures, including pilings. They don't care if they're creosoted or not, unfortunately. But also they will spawn on those nets that people have been putting out, and other things to try, as well as, of course, the cedar boughs as well. There's an interesting, oops, there we go. Herring used as food began with the discovery of herring bones dating back more than 12,000 years in a sediment core from the depths of Sechelt, Saanich Inlet in southern BC. On the southern end of Haida Gwaii, archaeologists found ancient herring bones dating to almost 11,000 years ago. The remains of meals eaten by the earliest occupants of the northwest coast. Yeah, herring have been used and abused. They've been sanctified, and yeah, they have had a very, I guess, tumultuous lifetime. They've been up and down in their life process. The populations coming and going from thousands of tons down to what we have now, which is one fishery basically. Okay, so there we are. This is from Roberts Creek. This is a photo I took a number of years ago. Herring eggs on seaweed, and you can see these guys are high and dry. They were up in the rack line on a high tide, and they would go out again on the next tide. There's an adult ready to spawn. So these are mature, and here are the milky waters created by milt from thousands of male herring. And this is just off Hornby, I believe. So just an amazing thing to see. Yeah, anyway. So, and here we have salmon feeding off of a herring ball, Hornby Island, and you can see here. So there's a major dependence on these little guys. Looking at this cross section of a beach area, you can see the low tide here. You can see the high tide line here. I have a mention here of pelagic spawners, so you can think of those anchovies spawning out further, out deeper. Then you look down here at the herring spawning area. So there's your interface there, low tide, right? And so just a bit above high tide sometimes, and definitely along the area where the eelgrass is growing and the other marine algae. Up above, you go up here and you're going to see the area where the sand lance and surf smelt spawn. So right from the the toe of the bank, where you have the log line, and down to where the major cobbles begin. So any of that area there is where you'd find them spawning. Okay, and so just some examples of some beaches. Rack, you'll see beach rack mentioned everywhere. Beach rack is that high tide mark where the tide deposits seaweeds, but not just seaweeds, but also sticks and bits and pieces and debris and whatever else. But that's the rack line. And often in that rack line, there may be eggs as well during spawning season. You can see here, this is the spawning area. So below that high and down, and often when you're looking at the tides, you can actually see the lines that are created by the tides as they come and go. Okay, and so this is just more of the same here. And this is the area. And here again, this one actually it looks almost like a roadway. And so this would have been your high tide here. This would have been your low high tide here. And so that area. And so when we sampled, you can see the tape here. It's a 30-meter section. Okay, this is the same. Just different beaches, different characteristics, different slopes, different times of day, different weeks. All has a bearing on what you're looking at. Changes that happen in between tides are incredible. Here's a really nice flat example. You can see that you've got your log line very clearly denoted, and you can see the rack line here. And something interesting you see here, you see these two white lines? Those lines are lines that have what you basically call shell hash. And shell hash is anything from mollusks to bivalves to say barnacle bits, and they are organic matter. And that organic matter is basically the same density as the forage fish eggs. So those eggs would have a high potential of being there in that area. So those are areas you really get excited about seeing. And there we go. So energy from the ocean. So these little guys that are in the oceans work their way up into being food for everybody from, oops, getting ahead of myself, from the seals to the orcas, because the orcas are eating the chinook, which in turn are eating the forage fish, and sea lions, seals, and actually a few species of whales, which directly eat them, directly harvest them out of the ocean. So this is where we get to the chinook salmon, the importance of forage fish to salmon diets. And as we know, the chinook salmon is the one of the main food sources of the endangered southern orca pod. And you see here that 72% of the diet of the chinook salmon is sand lance and herring. That's a big percentage. And those chinook, once again, are a major part of the diet of the southern resident orcas. Coho adults as well, 50% forage fish, 50% invertebrates. So if you're talking that, you think invertebrates, think planktons, okay, zooplanktons, phytoplanktons, and things bigger than that as well, krill. But also keep in mind, 50% of the diet is forage fish. And this is a little, did you know, when chinook is plentiful, orcas are known to produce calves. When there are less chinook, these whales are less likely to reproduce and experience more deaths. So that was a little blurb from World Wildlife Fund, who we've been working with lately. So once again, I just want to reiterate that they are very, very important for the diet of the chinook salmon. And those chinook are very, very important for the survival of the southern resident killer whales, or orca. Food web, just really quickly. So here we are, there's the herring and forage fish. And you can see here, there's the phytoplankton, which are feeding them. There are the zooplankton and krill, which are feeding them. And then you start to look at the relationships. So there it is, the salmon, which is feeding the resident orca. Then you go up to the humpback whale, which is directly eating those herring forage fish, directly to seals, directly to porpoises, saying up to squid, and then on up to sea lions. But I'm going to show you something in a minute that would question that connection. And then directly to marine birds, lots of those, seen that many, many, many times. And I think it is indirectly to, yeah, so coming up to hake, which in turn are eaten by many of these guys higher up in the food web. So super important. Here we are. This is my comment about sea lions being a direct connection in the food web. Here, this is taken by Bob in Howe Sound again. Amazing photo, and that's a sea lion gobbling down anchovy right there, our evidence. So I'm going to now take you to our forage fish sampling. I'll speed up a little bit maybe. And I just wanted to tell you that we're currently doing our sampling supported by the World Wildlife Fund, which is great. And we are sampling in the early fall through to the end of March. We are using a method which improves on what we had done in the past, and that's called the vortex method. And I'll show you how that works in a minute. And so we have training. We get trained in doing this. And you can see here, I've got the 2 jars in this illustration. This is the old method we used. It was called winnowing, where we manually took our samples after they'd been screened. And we ended up with 3/4 of a jar. Those are 300 ml jars. And that was a lot of sample for our volunteers to go through. An incredible amount of patience and time that people put in on this. So now you look at what we have there, we probably have 2 or 3 tablespoons of sample. So we have abbreviated that process to an incredible amount. So it's wonderful. Positives, by the way, have been found in numerous areas. Ark Road, which is in Sechelt Inlet, it's the boat launch site. Was positive, has been positive for sand lance, Pacific sand lance. Davis Bay has been positive for sand lance and surf smelt. Half Moon Bay, Welcome Beach, sand lance, and potentially surf smelt. I'm going on memory here. And Bonnybrook and Gibson's Creek, actually. So we do have these critters around. Unfortunately, we haven't seen huge numbers. But we do find the occasional eggs, so we know that they're still existing. So there he is. We are. This is Ark Road. There's a little boat launch, and you see that line that parallels the shoreline. That is a 30-meter transect, and that's between the high and the last low high that we take our sample, and they're taken with a scoop. And then these are taken then, and what she's holding here, Grace is holding in her hands, is a set of 3 screens. And so each of these converted screens, and the bottom has buckets, I should say, has a screen in the bottom running from coarse, medium to fine. Okay, and that from the fine is where we get our sample. And there's Marmot Road, and you can see there's, once again, there's the three are actually the big flower pots is what they are. And they have been modified with the screens in them. And this is the setup. If you want to, ever see one, I can, give me a shout, give me an email, and I'll show you the system. So here we have a tote. Okay, so this is one of the large totes. We cut a hole in the lid over here so that the pump will pump some of this water up and into this wonderful vortex bowl, which is actually from a mining company. And you see it over here. Okay, and so what it does is the water comes up with the pump, goes into this bowl, flows in a circular pattern like so. We enhance that by stirring with a spatula. And what happens is the organics float up. Okay, and so when those organics float up, they have this raised, there's a raised center in it that's got an opening. And so those organics will come up, and a few other bits. And they're about the same density, and they go through, and they're caught right here in this 0.5 millimeter sieve. Ours is actually hanging down here. So that's where our sample comes from. Okay, and of course, no, we don't plug it into a tree. We have a little portable battery that we bring with us. Okay. And there we are, and you can see it in action. So there's the screens. There is the pump in here. The battery is sitting somewhere at the end of this wire, and we time it. So it's over a 3-minute period of time. And whatever comes down and into this screen is what we're hoping will contain some of those eggs. And the eggs are tiny. Remember, they're 1 millimeter on average. And so not visible to the naked eye unless there's an incredibly heavy spawn. And we haven't been blessed with that so far, unfortunately. Okay, so here's Davis Bay. And so this is where we have found eggs. And so not always so easy to define what is going on, but you can see that basically there was definitely a tidal pattern going on here. And we just sort of tried to weasel our way in the middle there. Being winter, we have some cold working conditions. Here's Welcome Beach, and that's another positive. And you can see very clearly here where we have deposition left from a high tide, winter weather, and then in here. So we've got a really nice clear sampling zone there. And this is Lambs Bay. Unfortunately, this was most recent, and we did not, unfortunately, have a positive there, but we had some nice weather, that's for sure. Sampling with our masks. And here's what we are looking at again. So once again, I guess I could call this a quiz for you and ask you what these are, but this one has sand grains attached to it. So if you remember, this would be the one that had the sticky shell or outer shell and the egg, and that one is the sandlands. Okay, this little one over here, you notice this looks like it's coming out of its shell. When they first are fertilized, these little ones will, the egg shell folds over on itself and it forms that peduncle, that appendage I was telling you about. Okay, so this is forming down here, and that's the sticky attachment point for those eggs. If you look over here at this one, oops, well, didn't mean to click that. If you look at this one, you can see that they're all the angular looking sand grains, really quite beautiful, quite a few of them. But you look for those weird looking, not so angular bits, okay? And so if I'm looking here, I'm seeing one here, one here, one here, one here, and a few more. Maybe at the end we can do a guess on how many eggs were actually on that picture. So that's what the volunteers are looking for when they're going through the sample. And here's an example of a heavy spawn. No, I'm sorry to say it wasn't us, but you can see them. See all these little guys here. And you got to remember this is quite magnified, but that's how it looks. So that's how those little eggs look. Okay. And here we have something that is very, very dear to my heart as well, and very closely related to those forage fish. And that is the eelgrass. Okay, so it is growing offshore because I've mapped a lot of it. I have seen the relationship between the sandy beaches and the eelgrass growing offshore. Eelgrass likes to grow in sandy areas. And so if we have that, it's a perfect complement for the forage fish because those little ones will just hatch and they'll just roll their way out there. They might even just get caught up in there because they're still so small, but that's where they are and that's where they will grow and be protected naturally. So very important. And yeah, the perfect complement. Sandy beach with shade providing overhanging vegetation, as we see here, it's shade. Offshore eelgrass providing rearing habitat for those sandlands and surf smelt. And there we are. So that's my presentation. And I wanted to say right now for a really, really huge thank you to all our volunteers that we've had over all these years. And a big thank you to the Sunshine Coast Conservation Association for the invitation to do this presentation and for their support in many of my ventures over the years. So if you want any more information, feel free to contact me right here. There's my email. And we have a little web page as well, which is great. And that's the Sunshine, or not Sunshine Coast, it's the friendsofforagefish.com. So there we go. I will stop sharing my screen now so I can see you. There we are. And yeah, if you have any questions or anything, that's great. Love them. Questions are good.
Thank you, Dianne. That was amazing. I speak on behalf of everyone here when I now understand that they are not just little fish. They are a lot more than that. So thank you. That is so great.
You're welcome.
I thought I would now just open up if people have questions, feel free to put them in the chat box. We have one question so far from the chair of the SCCA, Leanne, and so I thought I'd start with that one. Potentially you've kind of answered this already with lots of the amazing photographs of the beaches around here, but we're wondering if there's any particular productive beaches, particularly productive beaches locally that you have found any of the forage fish eggs.
Yes, there's a funny little beach. It's what do they call it? Sandbox Beach, and it's in Half Moon Bay, and it's on the way to the government dock, and it's a tiny little regional park. It is 30 meters exactly. That's it, 30 meters, and we have had positives there. I think every time we sampled, we discovered it by accident. So how we used to do our sampling is we would commit to doing 2 beaches long term, but we would do a blitz once or twice a year. And so we would do what we called it, I think it was a dash, dip, and dine. And we'd have a barbecue after, and we'd, make it fun. And we did this little beach because it was a little beach and it was just looked perfect. And it was. We had, I'm thinking we had 3 positives there. And no, we didn't ever see, it was never heavy enough to be seen, but we had positive results from doing the sample analysis. So that's the one that always sticks in my mind because it's so tiny. In Sechelt Inlet, where we've been working lately, looking at mapping eelgrass and looking at the beaches, there are many little pocket beaches like that. We call them pocket beaches because they're so tiny, but they just look like they would be wonderful candidates. But it's, a case of how do you get there, and how do you, do all of that. It's not simple. When it's a beach like Davis Bay, you can walk there and it's simple. But if it's tiny and out of the way, say, several kilometers up Sechelt Inlet or something, it's not quite so easy. But they're so important to know about because whatever we do there is going to have an impact on them.
Thank you. And I'm seeing lots of amazing questions coming in here, so I'm hoping you're okay to answer a few more.
Sure.
So we have a question from Terry, who's wondering if you know if humpback whales eat sand lance on the coast. You mentioned some of the other whales, but maybe specifically the baleen whales like humpbacks. They eat.
Yes. I don't know a lot about whales. I gotta be straight up about that. But I was even wondering about the gray whales, Terry, because when we had the grays come and scooping at the shorelines, I'm saying to myself, I know they're picking up all sorts of mollusks and whatever else, but I'm wondering if they're also picking up things like sand lance, which very well could be because that's where they spend their time, buried in that sand, right? And they're sitting there, sitting ducks for this whale to just come along and scoop them up. But yes, they do. They are definitely directly food source for some of the filter feeders, right? Some of the filter feeding whales. No question there. And it is, I know, sand lance, so that's the species. It seems anyhow that I've seen photographs of and whatnot.
Thanks, Dianne. The next question comes from Ruth, who's wondering, and I was actually curious about this as well, what are some of the greatest threats to forage fish? Does climate change impact them? Is the temperature sensitivity for them? What would be some of the greater threats?
Well, I hate to be negative, but we are. What is going on and is, I see a problem, is that we are going lower and lower in the food chain to obtain things that we think we need. Okay, so now instead of staying with the larger fish, such as, you know, the salmon and the whatever, you know, tuna, all of those guys, we're now working our way down to the smaller fish so that the forage fish such as herring and anchovy and sand lance, they're they're not considered a commercial fish, but just the same, they're being caught and used for things like fish meal, fertilizer, things that aren't crucial. They're not essential to our survival. And by taking those, they're leaving a gap in that food web, right? So that gap is crucial. So what do those Chinook eat now? 72%, if those forage fish are gone or diminished very much in numbers, where do they go? What do they eat instead? So that is probably, unfortunately, what I feel is the main challenge to their survival. Climate change doesn't help things. You know, it's all related. But you know, what we choose to do or not to do, or how we can regulate, certainly will make a difference for those fish.
Thank you.
Holly, you're
There, you were muted somehow.
Was I muted? There we go.
I couldn't hear you. Now hear you now.
Sorry, I'm back. That's the saying of the year. You're on mute. I'm guilty of it.
Oh, you're gone again.
You can't hear me?
Now I got you. You're coming and going.
Ooh, interesting.
Is that the same for everybody?
yeah.
Can you hear me now?
Perfectly.
Okay, I'll try to speak clearly.
Not too clear. Not too clear. It's Saturday night after all.
The next question is about research. So how is the research coordinated with other organizations on the coast, like pods, and then broader across the province?
Yes. So we have now a newsletter, not that we produce, but Mabry over in Vancouver Island University has sort of taken up the torch with the World Wildlife Fund to create newsletters to keep us all together, all us little groups. So Jen Blancard and I from Pods, we work together. They're sort of the new kids on the block, not really, but in terms they are. And so they trained up, we helped organize training for them to do the sampling. So now they're sampling, and we often will do something I didn't speak to you about was eDNA sampling too, which we are doing now a small bit of for DFO actually. So we might do 10 samples in one season. And that means, you know, you wear your gloves so you don't contaminate, and you take your samples and then you seal them up and freeze them and fire them off to PBS over in Nanaimo. But anyhow, so, okay, what was that question again?
It was just about coordinated research efforts. So
Right, yeah. So basically what's going on now is the World Wildlife Fund has sort of taken on the role. And so all of our data goes, well, what ours basically goes to Vancouver Island University, and from there, they are sort of a central repository. And from there, they will send it off to World Wildlife Fund. And so, yeah, they've taken up the torch to ensure, or hope to ensure, that potential beaches are targeted, and that we will end up with a coast-wide map of, you know, beaches that are potential, and then beaches that are positive or negative. So yeah, that's what the goal is, to have that central map, and that will be publicly available. And that's really important. So we want it to be available to everyone, you know, anyone that wants to see this, but also to the people that can impact it. So whether you're a shoreline property owner, or whether you are industrial working in the nearshore area, or whether you're developing or whatever else, you know, putting in docks, all of those things, then this is another step in that process. This is some baseline data so that it is considered before the job is done.
Thank you. Okay, our next question comes from Damien, who's wondering if there are currently any protective measures in place to help forage fish.
Well, that's a good question. Protective measures. Nobody seems to really think that they're needing protecting. Well, that's not true. I guess the idea of having that baseline data so that when people are, proposing to do something that will have an impact on the shoreline, thus on the forage fish that are potentially there, that should be looked at before, or at least consulted before anything is done. So that should be a step in the process before it happens. So I think really, other than that, quotas for harvests, but I don't know if we can count on those to protect our forage fish.
Thank you. Our next question is around foot traffic on beaches, which is—
I was just reading that.
Yeah, considering these
yeah.
lay their eggs in what could be very populated places by humans and animals, other animals. How successful are egg life cycles or whatever while they're on the beach?
Right.
Do people trample them, or can they survive?
They're tough little bananas for sure. These little guys, these eggs are tough, which is really quite amazing. Probably one of the worst impacts is not so much people walking on the beaches, but driving on the beaches. So if you think about seaweed harvest is an industry in areas. You can think of some parts of the east coast of Vancouver Island where, yes, there are mountains of seaweed that are there after storms and whatnot, but people, especially that use it commercially, will drive a vehicle down there and use their machines, which they've driven down there, in order to harvest it. So the days of just being walking down with your pitchfork and your wheelbarrow are done. It's now a machine and a vehicle and a truck and whatever else to do that harvest. So that is what has impact for sure. Walking on a beach, not so much. First of all, your timing would have to be, if you're looking at the winter spawners, I can tell you right now that they're probably going to be spawning in the middle of the night. And that's when you've got, your nice high tides and all of the perfect things for them, the full moon. And so the odds of you going down there and walking on them and causing a problem is negligible. If you want to think about it that way, I suppose if you, the chances are very low that you're going to cause problems just by walking on the beaches. Like if you have hundreds of people, maybe, but they're going to be in the sand as well, because remember, your water is always moving like this and in all directions, really. You got your tides, but you also have your wave action, and you also have, winds, the whole works. And so those little guys they're down there a little bit, and they're probably just fine. Pretty tough. They're pretty tough.
Thank you, and great question, Talia. Thank you for that. We have another question from Terry around if you've seen sand lance spawning on the the Sechelt Peninsula.
No. No. Try Dunda Rave in Vancouver. Try Wreck Beach in Vancouver. But no, I have not. And in many years I have not. So if you see him, I want you to give me a call, because I'll be out there because I would really love to. And Terry, yes, you have a privilege, I must say, to have seen that. Yeah, for sure.
Thanks, Diane. And I'll pop your contact information into this chat box again. That was your last slide, so people can contact you if they—
Oh, sure. Yes, please.
Exciting. We have a question here about the status of puffins in the area. I'm assuming puffins eat forage fish?
Yes, they do.
I didn't know that we had puffins, do we?
I don't know how close, to be honest. I can't tell you how close they are, but they're island residents, aren't they? That's where they do their thing. And I'm afraid to say I cannot answer that one. I don't know what the status is. We don't seem that they really do love sandlands. Apparently, I was reading something about these recently, and when they're feeding their young, the young are able to eat those long, skinny fish really easily, and so that's why they love the sandlance, say, rather than a smelt, which is very cool. And so, if there's still sandlance around, we're going to have puffins, but I don't know what the status is.
Thank you. And so, yeah, I just put your contact info in that chat there. for everyone
Thank
to
you.
see.
Yeah, great.
I have a question here, and I just want to make sure I'm getting it right. Penny, do you mind unmute? I'm going to ask you to unmute here. Maybe you can ask the question yourself. I just don't want to say it wrong, so I know what you're asking.
It got pretty convoluted as I got interrupted while typing. And hi, Diane. It's been a long
Hi.
time since.
Yeah, hi, Penny. Yeah, good to see you.
Yes. The Garden Club would still love to have you
Hmm.
include us in anything that could happen or might happen. But as you know, I live on the Sechelt Inlet. And I just wondered if there's anything that we can do, like we clear a path of rocks every spring so that we can drag the kayaks down to the water. Is that wrong? Or how can we protect the area, the small area of beach, rocky beach that we,
Yeah, you have a cobble beach, don't you, Penny?
well, lots of rocks with
Yeah,
mussels. Is
yeah,
that probably-
cobbles, yeah,
Yeah.
basically.
And so
Yeah.
we do, move the stones aside so we have a
Right.
pathway. And is that a danger to?
Uh, well, basically what you're looking at in your beach area is spawning that's going to happen. If it happens, will be further out where the sand is.
And the eelgrass is not that far either.
It's
So
not really. That's a tough question. My instinct would tell me the less you disturb your beach, the better. So if
yeah,
you have one walkway to get down to the beach, so be it. That's
Yeah.
one. Don't create 10. Just
No,
keep it to
no.
one.
we
So
put 7 or 8 feet so
yeah,
2 people can carry 2 kayaks.
yeah. So keep it to
Okay.
a minimum. Keep your disturbances to a minimum.
Right.
Yeah, and because that cobble beach in itself is important.
So would any of these guys spawn there, or is it just all
No.
the other little people we see there?
It's all those other little people. I don't
Okay.
think you're going to have spawning there. I'd probably have to look at. You don't have any sand at all in the high. I don't think you do, do you?
No, just in the lower.
Yeah. So if there's any spawning that happens, it's going to be at the end of the cobble. If there's some sand before the eelgrass starts, might be some in that area.
Yeah, there's
Yeah.
probably 30, 40 feet till the eelgrass.
Yeah. And
So
so
there might be something in, but that's just plain sand. So they would spawn in there?
it's possible. It's possible. They're spawning in a depth of water. So yeah, it's very possible that they could spawn in there, and that eelgrass is quite an attractant, but it's not going to be sandlance and surf smelt. It could be sandlance, right?
Okay.
Because you saw the video. They're in the water, and not necessarily smelt are interesting because they rush up, and they'll rush up right to the water's edge, and they'll even wiggle their way up a little bit out of the water. And that's why they really love those high tides and the pull of the full moon. And that's when they will get right up there and spawn. So that occurrence is surf smelt, but sandlance versus that will be in water, of a depth, and they will, spawn in the sand there. So it's possible. I don't know.
Interesting. Okay. Well, thank you again for all you do.
Thanks for the great question, Penny. I'm just going to pop you back on mute here. Oh, great, you got it. So I'm just being mindful of the time. We've reached
Good.
our hour, and I see that we have
Yeah.
a couple more questions. So if anyone wants to hang around for just a couple more, we don't want to leave those ones out. So the second to last question we have is about the cyclical populations of anchovy and their history of abundance on the Sunshine Coast. Do you know anything about that, or could you speak to that, Dianne?
I was just looking at puffin stuff here, further north. Yes, that makes sense. Anchovy. They're cycles. You know, I have a lot to learn about those. I can tell you more about surf smelt and sand lance at this point in time than anchovy. Other than I have some amazing photos of the area by Soames where they showed up in 2017. When they were there, they were not spawning. I didn't know that at the time, but they spawned further out. But I did contact some people at UVic and ask the question, what was going on here? Because they were the ones that said to me, no, they're not spawning. They don't spawn there. They spawn out in the water. They're pelagic spawners. I said, okay, so what brought them all in, as well as all of the birds and the sea lions and the ducks and everybody? And they said, well, we can speculate that what was happening is the fish were schooled up, and the big predators, the sea lions, and there must have been, I think I counted 15, pushed them into shore. And in doing so, they then have a really easy feed, right? They can feed really, really easily. And so in doing that, of course, when they begin to feed, everybody else shows up. And so then you had the seals showed up, and they had the, you know, the gulls and everything else. And I was seeing these little guys on the shore, like stunned or dead. And you know, just sat there and watched for quite a long time. And I looked at the shore, and I was seeing, you remember the slide back towards the beginning, and I showed you the lines that I called rack lines and the shell hash lines. And they look like white lines. And those white lines, I was looking at this beach at Soames, and I said, wow, look at those, the shell hash lines. And I got closer and had a good look, and it wasn't, it was it was anchovy scales, thousands, millions of anchovy scales. And they were just these rows that had, I guess, washed in with the waves, and it was incredible. And so these little guys were dying and being eaten and killed and whatever else. And everybody was having a feast, and their scales were just washing up by the thousands. And it was quite an amazing thing. I have a photo, but it doesn't do it justice, but it was an amazing thing to see. As far as, yeah, how things are going with them, you know, I just don't know. I just don't know enough about the anchovy. I'm learning, but that in itself was truly amazing. I've fired off those photos to the folks at UVic, and there is a paper somewhere out there with some of those pictures in it. So there are people that are studying the anchovy now, and so that's, you know, a really good sign. So the universities are taking interest, and they're you know, starting to look at this. And of course, with Howe Sound becoming more and more, what would you say, vibrant with life, there's got to be more study done, right? It's just awesome to see the positive side of all of the life that is coming back. You know, those orcas showing. My husband was in Sechelt Inlet not long ago, and he saw 2 little ones and 3 adult orcas. And he said to me, I was fishing, and so I stopped the motor and I turned off my fish finder, right? And he said, we just sat there. And he said, they came up, and he said, I didn't know which ones they were, but they had straight up fins. And I've since then, Angela has told us, they're one of our forage fish regulars, that straight up and down fin is the non-residents, the transients. And he saw 3 adults. He said one was definitely a big bull, one that was a sort of a smallish one. He figured it was a young one, but he said one tiny one was half the size of the other one. So a little baby by the sound of it. I thought, oh, pretty special, pretty special. Yeah, and then he figured 2 females, but he wasn't sure. He said, you know, they were far enough away that he was seeing fins, but he said he saw this little fin, and he thought, what do we got here? And it was a little one. So they're there. Penny, do you see them from time to time? Yeah. So that's cool. So thanks so much, everyone, for coming and spending your Saturday evening with me. Now you can go and relax, and there's a little bit of daylight. Go for a walk. And
Yes, absolutely. Thank you so much, Dianne. I really
Yeah.
appreciate you spending time this evening to share some very valuable information with the SCCA and with the community of Sunshine Coasters. So for those of you who have joined us, if you've enjoyed tonight's webinar, I would really encourage you to consider supporting the SCCA's conservation initiatives with a donation or by becoming an annual member. I have a link in the chat box right now if you'd like to send us a donation to help further our conservation efforts or become a member. I'll also remind you that if you have registered for any of the films in the film festival, that those are available for viewing until the end of Tuesday, June 8th, World Oceans Day. And there are a few short films that are a really great follow-up from this evening's presentation. Most notably are the films from Hakai Institute, the one called Beauty and the Feast, and another short film called We Are the Herring, which is created by the Conservancy on Hornby Island. If you have not registered for the film festival, because the films and the webinars are separate, I will put that registration link in the chat box and you can go and register for those. And tomorrow we have 2 more amazing webinars in the afternoon and evening. So hopefully if you are at this webinar, you'll get a link for those ones in the morning and you can come join us tomorrow as well. We are pretty exciting. I know the Junos are tomorrow, but like this is where it's at. I don't know about you guys, but the red carpet will be rolled out. So thank you once again.
Yeah.
Thanks, Dianne. Thank you to everyone for joining.
Yep.
I hope you have a
Thank you.
wonderful rest of your Saturday. Take care, everyone.
And don't forget the wiggly fish. There's also the wiggly fish video. I forgot about that one. Okay. Thanks.
Thank you.